Now we'll take a look at another difference by their rules of series circuit according to if we put according to their circuit diagrams. Okay. Now here I will make a circuit diagram. Circuit diagram of series. Okay. And we use three components: source or the cell, and the second we use the lamp, and the third we use the ampere, and we also use the fourth one, which is the resistors. Okay. And what is the resistor component? Looks like a box. I thought I told you about the. Have I? Have I told you about the resistor component? Yes, resistor component. So we will take a look of a simple circuit of series. The first circuit in which we have a source. Bigger side represent the which sign? Can you tell me? Positive. Very good. And the smaller one? Very good. So we have the first diagram in which I put the source and the cell and the lamp. Okay. The current is flowing and the bulb lights up. The first diagram. Okay. There is nothing if there is a switch, if I turn off the switch, if I cut the connection, the bulb will shut down. This is a simple idea of the series circuit. But what if I put two or more than two cells, more than two bulbs, lamps in the circuit? What will happen then? This is the first circuit, and I will draw the second circuit here, the positive one, the negative one, and here this, this. If I put the two lamps here, if I put the three lamps here, okay. So yes, if these lamps are turned on, okay, turns on, they light up, they're glowing, they're brightening. What if I what is there is any circumstance happen with this the circuit? If I turn off, if I break down this first lamp, it will shut down. Okay, if this will shut down, the current is starting from here and going to their lamp, and after this lamp is delivering its energy to this one also, because current is remain the same in this whole circuit. In the series circuit, current is same, but the voltage is divided or shared. Okay, for example, if I got a 3 6 ampere of current, it's mean there is the first 3 ampere of current is used by the first lamp, and the next 3 ampere of current is used by the this lamp. Okay, first 3 ampere is come here, then it will transfer to the this one, and the previous 3 one will again receive by the this one. What if this lamp break down, and this breaking down of a one lamp will affect the next lamp? So this is a series circuit in which if one lamp break down, if one component in breakdown, it will affect the next component or maybe the previous one. Okay, this will happen in the series circuit with the same current, with the same component. Okay, if there is a same component, it means that there will be a same current received by the each component. That is also thing you have to write it down. If there are same components in the series circuit, you have to must mention the series circuit. Okay, then the current will be divided equally, and voltage also. Okay, if the components are the same, I'll made this the circuit is only for the length. Okay, now I will use the resistor again on the series circuit. Okay, this is the simple circuit in which I put a lamp here and I put a resistor here and I put the ampere meter also for the measurement of the current and ampere meter. So the current is coming from the source as a 6 ampere or the 6 volt. It's mean that if we are going to study about the resistor, that's mean if there is a different component, if it's mean that the current will be different with each of the component. First one will receive the 4 ampere and the next one will receive the 2 ampere. If we add these two, the current will become equals to the that the source is coming from the source. This is because of the resistors and the voltage. And the voltage is also different with each component. Okay, now this is the concept of the series circuit. I hope you understand each and everything of the series circuit. Can we move to the parallel circuit? Okay, so we will parallel circuit. So parallel circuit in which the current is divided but the voltage is same. For example, in the voltage, if the any component, any lamp break down, and that breaking down of one component will not affected the another one. Okay, if I made a simple circuit diagram here, I put the ampere meter here and I will put the circuit diagram, yes, here, and here the ampere meter also. This is the form of the branches. Okay, it is the form in the form of branches. So this is also okay. Got it? So if the current is coming from the source, this is about the 8 ampere. It's mean that current will be divided, will be shared to each loop. Okay? So it is in the form of 8 if we have to divide the current. So 4 will be here, 4 ampere, 2 ampere, 2 ampere. 4, 5, 6, 7, 8. If we add these three, then the adding up these three current of these components will be equals to the total current which is coming from the source. This is because of the same components. Okay, this is because of the same components. For example, if we have here 9 ampere, it's mean that 3 ampere, 3 ampere, and then 3 ampere. If I use a 9 ampere current is coming from the source, it's mean that the current will be divided to the each same component is in an equal form because of the same component. What if we change the component form? Here, this is the ampere meter. If I put the lamp here, and now I put a resistor here. Okay, the lamp again and the resistor again, the continuous loop, the branches. So it's mean that we have to use the current like 8. Okay, 8. That means 4, 5, 6, 7, 8. So now we have to divide this 8 ampere of current which is coming from the source in a different form. It's mean these two components will receive the same, like 2 into 2, 1, 2, 3, 4. Then these two will receive the same, 1, 2, 3, 4, 3 and 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. For example, if we have 9 pair of current here, so the this circuit in which we use a bulb, a lamp, and this is also used by the lamp, and these two is used by the resistors. So these two will receive the same current because of their same component, and these two will receive the same current because of their same component. If the component changes, then the current will be changes among them. So this is the idea about what how is current is traveling in the parallel circuit. No, current is divided, but the voltage remains the same. So if the story about the voltage, that's mean if I use again the same component, okay, the lamp, and here we also have the lamp. Here we have the 2 amperes, 2 volts of the voltage is coming from the source. It's mean that here we also have a 1 volt and here we have a 1 volt. The voltage is same. The voltage is same among the each component. Okay. If I change the components, if I put resist current a lamp here, and if I put resistor here, for example, the 2 volt of the 3 volt is coming from the source. The lamp one will receive the 2 volt and the resistor one will receive the 1 volt because of the opposite component. Okay, you have to write the one thing here. In parallel circuit, in parallel circuits, the voltage is voltage or current will be divided equally if the components will remain same. Okay, if second point is if the components change, then the current or voltage will be divided unequally. Okay, unequally. This is the whole concept, whole idea of the parallel circuit and the series circuit.